So, as I promised previously, I was going to start working on sending responses back from the server. So that's what I did today. Not gonna lie, I've honestly been in the trenches this week, and I haven't been able to do as much work. But I get Friday off for 4th of July, so you already know I'm gonna be grinding on this and gonna be posting some videos, hopefully some big updates. But let me talk about what I did today. So, basically, I made another enum class for some common HTTP response codes. I looked up, and there are way more than these, obviously, but these are just some of the common ones that I've seen before that I figured I would include to start. I figured it made sense to treat this as an enum because this is an important part of the information being returned by my server to the client, and so it makes sense to have it tied to some sort of class with some type safety rather than just a hard-coded string. If we look down here, I made this HTTP response class as well. I plan to add some other fields to it. I'm not sure exactly how I want it to work right now. Right now, I'm using this class method, so you don't have to actually create an instance of this class, but I think going forward, I will probably end up creating an instance of the class, storing some attributes with the constructor, and then maybe calling this class method to send the response to the client. But this isn't the final version of this class, most likely, but this is just the minimal working example that I wrote for the video tonight. So if you look, we take in the status code, which is one of these HTTP status code enum types, and we take in a body of the response, which in this case is just a string. Oftentimes, you might want to return valid JSON. That'll be something I'll probably do where I might do a separate body class and then have there be different subclasses or different fields within that class that specify valid response types. But just for this example, we are taking in a string, and then obviously we're returning bytes because that's what's being sent by our socket. So here, I'm just doing a very simple formulation. So you respond with the HTTP protocol version we're using, the status code value, which is 200, and then the status code, which just says OK. Um, and then I'm just saying connection closed. So we receive the request from the client. We verify that we received it, send that information back to the client, and then close the connection. So what I did is I'm taking this iterable of strings and I'm joining them on carriage return new line. So all of this stuff gets joined on carriage return new line as you'd expect, and then we add a double carriage return new line at the end to separate the response from the body. And then here in the body, we just add this string to the end, and then we take this whole thing and we encode it to UTF-8. So notice we're manually injecting these carriage return line feeds to match the structure that these HTTP responses expect, with the single carriage return line feeds separating individual lines, and then the double ones separating the headers from the body. So now, if we go here, what I used to do is I used to just have this client socket.send method be sending a raw bytes object that just says hello back from the server. But now I'm taking this HTTP request class, I'm invoking the class method, the send response class method here, and we're passing in the OK status code, which has a value of 200, and then the body that we're attaching along with it just says request received, closing connection. And then we're actually closing the connection here with client socket.close. So if you remember, what happens is as we accept incoming connections on our TCP server, we create a client socket and client address object for each of those incoming connections. Then we're able to receive data from them, and now this is splitting all of the data up, and here we're just printing out the data that we extracted from the incoming request. But we're using the same object which we created when the request was first accepted and opened to close it. So that means that we're really taking in one HTTP request and then we're closing it right after. So there are a couple ways to do it. I think generally older HTTP protocols do this, where you accept one incoming request, parse it, respond to it, and then close the connection. And newer ones allow you to keep an open, persistent connection until both sides decide, or I guess you probably only need one side to decide that they want to close the connection. But regardless, we're just trying to get a minimal working example here. So this is what I'm going with. So we're just going to immediately close the connection upon sending our response. So let me start up the server real quick. And now let me pull in git bash. So again, we're just going to use curl. To send our request. So since we're doing just regular curl, what this means is that it's just going to send a GET request by default, and that's what we're going to see come up here in the terminal. So let me send it. So here we see we got a GET request, HTTP protocol 1.1. The host that was sent in the headers was localhost port 8080, which is exactly what this server is running on. And then our agent was curl version 8.15. That's all right. And then this accepts thing, I think, just automatically populates every time. And now let's look about what we got back. So we did not get any errors. If you remember in the previous videos when I was sending these curl requests, I was getting errors after initiating the requests that I was getting invalid outputs sent back from the server because I was just sending raw bytes that said hello back to the server. It wasn't formatted in a way that adhered to the HTTP convention. But now, since we're going through the trouble of making sure that these responses that we send back match the HTTP convention, we're not getting any errors. And we can actually see we get the body back here. So the body said request received closing connection in string format, which we encoded to bytes. And that is what our client in this case, which is just the curl tool, received back. So this opens up the opportunity to handle all sorts of requests. So generally, what I think I'm going to do is I'm going to expand out this HTTP response class, and then I'm going to have various methods to handle the various types of requests that can be made. So, I mean, there's only 9 valid request types that can be sent to my server as defined by the HTTP convention. So I really don't think it would be that cumbersome to have 9 individual methods within this class. Maybe I'll think of a better way to do it that's more modular, but even then, I think writing 9 distinct methods probably would not be that hard. And especially, I expect a lot of the functionality to be the same, like joining these new lines and encoding. This could probably be something that I write as one function and then call it 9 times whenever it's needed to actually format the response. But yeah, generally, I mean, I guess you could say that this project is done if we want to be very if we want to talk about just a very minimal example. I mean, I've created a server which can receive HTTP requests and respond to them in a valid way, but obviously I want to make this a more I want to make this a better project. I don't want it to be just like a simple, you know, how do I want to phrase this? I don't want this project just to be something that I quickly rush out the door as soon as I meet the minimum requirements. I want to make it a good project. I want to make it worthwhile. And so to do that, I want to expand this to obviously send more status codes back depending on what the person is sending in their request. I want to probably do something. I've been thinking about making a mock database with a CSV file where I write things to the mock database when the person sends post requests, and then delete things from that mock database when they send delete requests, and then send things back when they make get requests. I think that would be a really simple way to demonstrate the core utility of HTTP requests. So storing some toy database in a CSV and letting the CSV get dynamically updated and having data retrieved from it by making HTTP requests from a client like curl. I don't expect to change the client. I think the client using curl is probably an easy way to do this. I could also use the requests library just to double check, and I think maybe if I write a test suite for this project, I could use the requests library to test all of this. Because I mean, at the end of the day, the Python requests library is doing the same thing that curl is doing. So that'll probably be my next step, is validate that I'm getting the same expected behavior back when I send requests with the Python requests library. But I mean, it should be doing the exact same thing that curl is doing, but I think having my tests sent to the server be coming from a Python script gives me a little bit more flexibility than a terminal tool like curl. But yeah, that's basically what I worked on today. Like I said, I've really been in the trenches this week, so I've not been able to make much progress on a day by day basis. But, we're getting there. We sent our first response back today, which is big. And I know what I got to do to get this thing into a more operational position. And so, trust me, we're going to make some big progress over the next, honestly, after tomorrow. Uh, I should be in a good spot to start making some big progress. And you guys will see the end of this project hopefully by the end of the week, and I can start on a new project. I know I talked about potentially doing some machine learning oriented videos. I was thinking it would be cool to maybe do like one machine learning project for every two CS projects that I do. Obviously, the point of this series is to do CS self study, and that's what I've been sticking with, and that's what I'll continue to stick with. But maybe if I have extra time, like on the weekends, I can post some videos that aren't about CS self study where I show you guys how to implement some machine learning models or algorithms. I think that'd be helpful, and it'd be nice to have an educational aspect to this channel where obviously there's the aspect of me learning and you guys following along my journey, but I think it'd be cool for me to offer stuff as far as sharing my expertise and my knowledge about a field that I'm more mature in and that I'm not actively trying to just learn. But yeah, let me know your guys' thoughts on that, and that really concludes everything that I wanted to say in this recap video.